Okay, I think we can start. It's time here, 9:45. So, hello everyone. My name is Bruno Capuano. I am back again to talk this time in a technical session. More technical, it's not very deep, but it's going to be a fun one about, hey, let's hack a drone, a cheap drone, and do some AI stuff on the drone. As I said, my name is Bruno Capuano. I lead innovation in Avanade, Canada. I'm not a Canadian, you probably noticed the accent, came from Spain, been here for a couple of years, and I work in Avanade in leading innovation, and I've also been an MVP for more than 10 years. I really like this session. I really like to talk about this one because it's kind of different. It's kind of not the standard technical session that you're going to do, it's something fun. But before going there, let me start with a big thanks to all of the sponsors that made the Code PaLOusa event possible. I never been in Code PaLOusa, it's going to be my first time, then COVID happened, so sadly I couldn't be there face to face. I would really love to do this session live, but thanks to all of his sponsors and the work behind the scenes for Chad, Rebecca, and all of the people, this is amazing. So thank you very much to all of them, and let's start. Let's see what we can do. So, like yesterday and every session, sorry about the crappy animations and demos. You are not going to see anything nearly close to amazing. It's going to be all about crappy, so sorry about that. And what we are going to do today, we are going to do I'm going to do most of the coding in Python. So if you know Python, that will be great. If not, it's a very easy language to understand. Also, I am going to use a couple of community services to do the AI part, and they are going to do some custom AI on top of this. So if you know something about that, that will be also a plus. I am going to talk about a little about face recognition, Docker, and communication protocols. It's not going to be a deep session, so if you want to know more, I'm happy to chat later about this, but this is the main concept of the stuff that I'm going to show today. But again, if you don't know anything about this is a level 100 session, so it's going to be easy to follow. And final disclaimer, I really love this slide because what you are going to see today is a lot of code, but please do not use this code in production. This is just to showcase the art of the possible, but it's up to you if you want to use it or not. So, coming here, what I'm going to do? I'm going to show you how using this cheap drone we can do stuff on top of the drone. And I said cheap drone because there are professional drones that they have professional SDKs and you can program these drones. These drones are usually expensive, over $1,000 or a couple of $1,000. And this is kind of a toy. This is really a toy. I mean, it's a $100 drone that you can get. It's not very expensive. And if you go for, I don't know, any crazy promotion or Black Friday or whatever, you can even get this cheaper at $60. So it's kind of a very cheap drone, but I really like because this has a lot of powerful features if you want to play around. So, in example, the camera is not a full HD camera, but it's a 720p resolution cameras, which is good enough. And then it has two Wi-Fi antenna, two wireless antenna that allows you to connect via Wi-Fi. So it's kind of nice because you can connect here and it gives you depending on where you are, in the open field, you can have between 20 and 30 meters of connection. In a closed environment with a lot of noise, like a house, between 5 or 10 meters is good enough. But it's really cool, and it has a lot of sensors. It has a couple of wars, propeller wars. You can use it. And as I said, it's a toy, but give us the chance to basically play with the toy. It's also, the battery is good. It gives you 10, 15 minutes of flying time. It's also cheap. So because it's cheap, you can get extra batteries. I have a kit here which allows me to have a couple of extra batteries. They are very small, but you can use it. So I have these batteries. And because also it's a toy, let me open here you can get extra supplements like the propeller wards. I have a couple more because from time to time you break your drone. So last week or 2 weeks ago, it was basically killed. My kids use this for play, and hey, it's easy to maintain basically. But it's there, and I really like it, and it's very stable, works fine. But what I really like is that when we started to play with this drone, and it all started at the beginning of this year, a colleague, Daniel, told me about this drone, and he said, you know what, this drone has an SDK. So I started to dig around to try to find the SDK. I couldn't find the SDK, but I see in the main page of the drone, and also in the company behind the drone, Spice Robotic, that they talk about that you can do Scratch programming for kids for the drone. And if you know Scratch, Scratch is a block-based programming environment. So where you say, okay, take off, land, do a flip, move forward, move backward, go up, down, or whatever. So I was starting to think, if they have a Scratch for kids allowing to interact with the drone, there should be an SDK. I couldn't find the SDK anywhere. I was starting to dig around, I couldn't find. I even asked the company, never get a response, but somewhere there, deep in their page, I found a PDF. You can find the URL in the slides, and the PDF talk about an SDK. I never found the SDK, but talk about the SDK. And there are a couple of parts here. I highlighted the big ones, which basically explains how to interact and work with the drone. So basically, when you connect your phone or your computer to the drone is going to start the Wi-Fi connection, and then it's going to open 3 UDP ports. One UDP port is going to be used to read the state, to read information for the drone. So you're going to be able to read the battery level, the temperature, how much time, the time of flight of the drone, the inclination and the pitch, all of this info. Other port is to send information. This is where you are going to send commands to the drone. So in example, the first command that you need to send when you are connected to the drone is a command with a text command. It needs to be a string with command and UTF-8, and the drone is going to start to work in SDK mode. And then you need to start, you can send other commands like take off, land, move forward, up X, down X, move it. So you can send a lot of things. Sadly, because it's UDP, you don't know what's happened there. You send the command and you don't know if it's there or not. And you only probably have a response, which is going to be okay or error. That's it. So this is the only thing that you have. And we also have a third UDP port for the camera. So when you start to interact with the drone, you can open also a third port and interact with the camera and take a look at the camera view. This is all amazing, but it's UDP. And this is a very freaking old UDP joke. The problem with UDP is that you send a package with the commands, and you don't know if it's there or not. So there is no way to know if you send 2 commands, which one, even if you say A and B, and then B, maybe B is first there and then A, or A never there. So it's kind of crazy, but hey, it's UDP. It's nice. It's what we have. Let's play with this. So because you need to connect to the drone using Wi-Fi, what I am doing here is I have my PC connected via a network cable to one. I have a developed node of mesh here at home. So I usually connect by Wi-Fi, but here today I connect to a drone via a network cable, and I am going to connect my computer via Wi-Fi to the drone. And I explain this because from time to time the connection drops. Remember, this is a toy, it's not a professional drone. So it gets disconnected, I get disconnected from the internet, it's a mess. It's supposed to work, I test everything a couple of minutes before. If it doesn't, I have videos to show everything, but it's a tricky environment. So let me show you how we are going to manage the connection. So what I have here, I have an amazing terminal, Windows terminal, and I have a command to, when I have my drone, let me get the drone here. This is the drone, as you see, it's a freaking toy. I want to change and put the camera later. When I turn this on, I am going to have a LED blinking on there, and when the drone is ready to start to connect, what I will have here, I can see that the drone is going to be part of my network. So if I go to my wireless network, you can see here that I have the drone. So I can connect from here. I can even get here and automatically connect. Sadly, Windows 10 is not good for this. So what I am going to use, a command, a net sh command to wireless connect here, and I am going to use the old and amazing ping to see to check when I am connected. So I am showing this at the beginning because you are going to see a lot of this during this demo, which is basically, let's connect to the drone. So I connected to the drone, the ping is still out, and there it is, it's connected. So right now I am connected to the drone. And if I go to my network settings, I will see that I am connected to the drone. My wireless is connected to the internet. My drone is connected here internally. Again, this is mostly because I want to show you how I am going to connect and disconnect. You're going to see these commands and ping a lot of time today, but this is going to give you a sense of what we can do. So once I am connected, going back to the SDK, I was starting to see, okay, how should I create an SDK for the drone? So it's basically, I need to have two main actions here, which is basically send commands and read commands, and that's it. This is going to be the last slide that you're going to see here. Everything is going to be code right now. And if we are going to do this live, what I am going to do is probably send the first command, which is going to be command to start the SDK mode. And the next command is going to be take off. So you are going to see this flying. Because this is web, I am going to check the battery. And I'm also going to check the battery from the drone because I don't want to make the fly as the first demo, because if I hit the drone to the wall, and you've seen this in other demos, I am going to don't have any extra device to play around, so we need to stop here. I will do some not flying demos at the beginning and end with the flying demos. So let's start to check the battery. So let me show you how we can do this. And by the way, let me close this one. I don't need this one. So I am going to use, oops. All right, that's amazing. Visual Studio Code is updated. So I am going to use Visual Studio Code, and somewhere here, today is the 8th, I am going to create a new file, demo.py, a new Python file, and I am going to, I think it's fine there to read. Can you read the code? If someone needs bigger fonts, let me know in the chat. I will start to make the size, but basically I'm going to show you the ABC to connect to the drone. First, of course, I'm going to import a couple of libraries, sockets to manage the connection, time to do some tricky timeouts checking when I send in commands, and threading because I need to do this in different threadings. So once I have this, my next step will be, okay, let's write a couple of functions, a couple of operations to receive data from the drone. So here, I will declare an open later socket, but I am going to open the socket here in a while true response. So this is going to be running all the time, receiving chunks of data in 1024, the size for this. So this is going to run all the time, and this is going to give me my data and the response. And also, I am going to read for the other socket. Remember that we have 3 sockets, one for send information to read the states, and we can have OK or error, other to read the states. So we can get the battery, the flight time, everything, and the third one for the camera. So in the other, I am going to read the information from the drone, and I am going to split this because it's a big array, and I know that in this array, the battery is in item 21, so I will have the battery here. So this is my other read information. So my next step will be, okay, let's write some send information, send command function. So it's very similar. I am going to have a send command function with a command. This is going to be a string. And then I am writing here, checking for the time. And then I am going to send the command. Remember, UTF-8, this is important. It took me some time to realize that it needs to be formatted in UTF-8. And then when I have this, I am going to check the response variable, which is defined here. So I'll see if I have error or not. And if I have the response, I am going to return the response. If I don't have anything, I will return false. And I am going to check here the time from the beginning of the time to see if I have more than 5 seconds. So this is 2 lines of how you can write a timeout function here. I know there are better patterns, there are better ways to do this. That's why, going back to first slide, these are crappy demos. Then I have a couple of overloads here from send read commands, send control commands, basically to see what we have. So nothing important here. Keep on the idea that I will send the command here to the drone. So once I have here my send commands, my next step will be, okay, let's do the connection. And this is important also to understand that once I am connected to the drone, I know my IP. So because I know my IP and I know the default ports that is going to be open based on this PDF with the SDK, I can open here my 2 ports. I can open one port to, let me go to Subit. I can open here one port to send information, another to read the state. So this is basically the main one. This is the one that we want to use. The state socket to read the state and the client socket to send comments. And these two are defined here in the port 8889 and 8890. So this is the ABC of what we have. And of course, the IP is here because I know it here, and it's the same that I use in my ping command. So everything is starting to get connected. Let's move forward. Let's go and create two threads to start the reading and the send comments. And this is important because I don't want my main app to be collapsed and to be waiting for a response at any moment. So let's do this. Oh, it's starting to get some light here, so let me turn this on. So we need to have this, we need to basically start this in different threads so we can have everything running smoothly. So I will start two threads here in daemon mode, and once it's started, that's basically it. And then finally, I can write my application. And my application is freaking easy. I am going to define my battery. A battery variable is going to be in 0. I am going to send the first command to start this in the SDK mode. Then I'm going to send a read command for the battery. If I go back to my PDF here, one of the commands somewhere here, it's part of the PDF, the information that I have. It's not here, I need to open the PDF, but I have the battery to see how we can use it. And then I am going to wait 5 seconds and print the battery. I'm going to wait this just in case to see how it's happening. So let's run this. Let me copy the path. I will go back here. I will open. I have a specific environment here in Python environment in Anaconda to do this. So let me move here. We are here. Let me show you my files. This is the file that I just created. Today date 10/02/10/02. So this is us. I am not connected, so I need to go back here. I need to pick up my drone, turn it on, and when it's on, start to connect with the wireless. One more time. When the ping is returned, okay, there it is, I am connected. And once I am connected, what I can do is Python, let's go for demo, and it's going to run the demo. As I said, it's not very fancy, it's not going to do anything. It's going to show me that the battery for the drone is at 91%, but it does make a connection, which is good enough. But let me change something here so you can take a look of what else we are doing. So I am going to put a battery, I want to open the time sleep to 30 seconds, and I am going to print also all of the states that I have coming back for the drone. So what I am going to do here is I am going to show you, I'm still connected, yes, I am going to show you in real time, this is all of the info that I get from the drone. And if I start to move the drone around, this is me moving the drone, you can take a look how the first values are changing. So the pitch is 900 there. If I move it like this, it's going to change a lot. If I move it like this, it's going to change a lot. So right now I am connecting to the drone, and if the drone is flying, is moving and doing something, I am getting this info in real time. So I can check the drone, I can check what will happen. I am working in another demo, which is going to use Project Bonsai to analyze this information and to automatically fix and stable the drone. But take a look here. All of the info from the pitch, the roll, the yaw are changing. If I am moving the drone, so I'll go for 1,000 to, move here for 1,000 to 0 to other values. So let me put this smaller. So everything that I'm doing here is changing a long time. And then I have the aggregation here. I have all of the inclination, which is also changing when I am moving this. So this is the drone connect. This is how we can connect to the drone. Give me 1 second. Vale. Ese ruido abajo. ¿Será? Bueno, no sé qué hay. Hay un ruido abajo, no decimos nada. Hay ese ruido. I'm back. I'm sorry, I have the kids doing something in the back. So we are back. So let's recap what I just did. I created the demo, I created a couple of read commands and send commands. I send the command there, I read the battery, and I show the state. So my next step will be, okay, I have everything connected here, I can do stuff. Let's connect to the camera. Let's see what we can do with the camera. And this is the tricky part, because the camera it's open by UDP. The default port of the camera is 11,1109, 11, I'm sorry. So the first thing I tried to do is I tried to connect with VLC, and it didn't work. And it's weird because VLC basically connects to everything, but it couldn't make it work. Then I find the tool FFmpeg, and somehow it was there, it was nice, but it didn't work also. It was very late, it was very delayed here. I have almost a 5-second delay between what I am doing with the drone, you can see there, versus the drone feed. So it's kind of a creepy environment. So then I remember, I use a lot of Opencv. So I tried to say, okay, let's take a look and see if Opencv can help me to do this. So let's do an Opencv demo. Let's go back here to the demo, and let's create a new file, camera.python, and let's start with the code. So I am going to use the same code that I used before, but I am going to also import Opencv. I'm going to use Opencv here. And in my demo environment, if I go here and let me clean this, and if I open Python, there's Python. If I import Opencv, is there, and I print CV2 version, I am running right now, I'm using the 4.2 version of Opencv. This is good enough for my demos. So I have Python, I have Opencv here, so I can run my demos here. And as I said, this is the same amount of code that I used before. I have my receive data, I have my send command functions, the connection to the drone, and the main difference here is that I am going to, camera, yes, I am going to send the first command to start the SDK mode, the command, and then I'm going to send another command to start the streaming. So if I want to have the streaming, I need to send this command, so the drone is going to start the streaming. And when I have this, my next step will be, okay, let's open the camera drone. And this is important. The only thing that I need to do using Opencv to connect to the camera drone is to define an address. In this case, it's going to be UDP, the IP, and the port. And then I'm going to use Opencv like I use Opencv to capture a camera. So if I want to capture my main camera in my computer, or if I have two cameras, I can iterate through the name of the cameras or the index. Here, I am going to connect to this to this address, and it's going to connect to the camera. So that's basically it. I will this is defensive programming. I will wait some time here to see if everything works fine. And then I am going to display the camera with Opencv. And here, what I am going to do, I am going to still use the battery. I use the battery kind of a ping to also know how much battery I have here. And in an eternal loop, I am going, remember, this is Crappy programming. I'm going to read the command, send the command to read the battery value, and then using the camera open, the camera capture open from the drone, I am going to read the frame, I am going to resize the frame, and I am going to show the frame. So let's send this to Code PaLOusa camera, and I'm going to show this. And if I press the letter Q, I am going to close the app. The other important part here is that, and I learned this in the bad way, is that I need to, when I finish my application, I need to send a stream of command to the drone, because if not, the drone is going to be collapsed. This drone is going to be out. So I need to finish this. So I have my camera demo here. Let's go here to the drone. Let's show again the files. I have the camera created right now, and let's see if I am still connected to the drone. So I am not connected to the drone, so let's start with the ABC. Turn the drone, go to the other. It's going to wait for connect. This is my moment to drink some. It's not connecting. One more time. Let's turn it on. Yes, it is. Okay, now I'm connected, so I'm going to back here and I'm going to run my camera demo. So when I'm running my camera demo, what it's going to do, this is all output from the Opencv camera connection. So it's going to wait some time. And as you see here, I have here the Code PaLOusa camera, but the battery is 88%, and this is my drone. And if I start to move around my drone, this is me moving myself my drone. You can see here how I'm moving my drone. Let's go close to the camera. There's the camera. It's moving. It's working really, really decent. And I can start to play around and start to move. And again, from the original set of code that I have, I only had a couple of lines. And now I have my drone flying with my hand, and I have the chance to connect to the camera. If I want to do something else here, if I want to, in example, check how someone asked me in one of his demos, how fast is this working? So if I want to show the frames per second, and I'm going to use the frame per second a lot, what I am going to do is I am going to capture the time in each one of the loops iteration, and then after this, every time that I read a frame, I'm going to make some calculus here in order to show the frame, which is going to be the initial time versus the last time under one, and it's going to give me the frames per second. So this is kind of a different way to do this. And let's change this to Code PaLOusa with FPS. Let's run this demo. I'm still connected, yes. So right now, what I am going to have is going to be the demo, the drone connected, up and running. Let's do this. It's around 30 and 50 drones per second. So I'm sorry, frames per second. So it's kind of nice. It's kind of useful to do. I can go here, go up, start to look another set of figurines, everything here. And as I said, 50 seconds, 50 frames per second. It's very, very good. It's kind of a decent frame per second to work with something around AI. So once I have here everything up and running, in my next step, I can connect to the drone. I can send commands to the drone. I can read the drone status. I can even read the drone camera. So the idea here is, okay, what we can do? Let's start to do some stuff with the camera. We can have access to the camera, so we can do a lot of amazing things. Like in example, do some face recognition. And this is a very, very old GIF from Boris Babenko, but I really, really like it because this is face recognition ABC. So what I am going to do, I am going to do a couple of demos around this, using the camera. So we can do object detection. So I write a demo some time ago, how you can detect, in example, the HoloLens. You train a model, an AI model to detect specific objects. I'm going to show you later how to do this, but this is all around how we can do this kind of stuff. You can do face recognition, you can do face detectable feature. This is myself and my daughter playing around. You can see there everything. So the one that I'm going to use, the algorithm that I'm going to use to detect faces is one of the oldest one that is available there, is the Viola-Jones algorithm. It was written in the early 2000s. There is a lot of information, and the idea is that it uses a technique called the cascading classifier. So once I have an image, I'm going to convert this image to a grayscale, and it's going to start to do operation in this grayscale using sections. And once you have there, it's going to detect faces, basically using lines and shadows. It's not the best one, so it is not. I will not recommend the Viola-Jones for face recognition everywhere, but it's good to start, because also it's easy to implement with Opencv, because the only thing that you need in order to do this is to use an XML file, which is called the cascade recognition, and in the Git repository from Opencv, there are plenty of samples cascades to do face recognition, eye recognition, smile recognition, so we can use this. Again, it's not the best one, but it's good enough to use it for learning and training, and you can use this with 2 lines of code. Let me show you how we can use it. So let me show you how we can do face recognition with the drone. So go back here, let's create a new file, face PI, and again, I am going to reuse a lot of codes. I have everything here. This is the location where we can get the face cascade file. And the face cascade, by the way, is just an XML with a lot of nodes internally with what we can do, how we can do. We can do a 2-hour talking just how this works. It's not the idea, but the cool thing about this is once I have my project and I know how to connect to the drone, read the drone camera, the only thing that I need to do here, as you see, is the same code that I used before. I need to initialize my face cascade. And the way to do this is I am going to define a variable named face cascade, and I am going to say, hey, Opencv, open a cascade classifier, and this is the file. That's it. With this, I have a cascade classifier that I can use to analyze frames, to analyze pictures, looking for faces. So the next step is, again, very similar. I am going to have my eternal loop. I am going to, let's do this with Code PaLOusa faces. I am going to do my eternal loop, but once I have my frame, the frame from the camera from the drone, the next step will be, I will convert this frame to a grayscale picture, and then I am going to detect faces. So I'm going to use this gray here, and I am going to say, hey, face cascade, you know how to detect faces? Detect faces here. And for each detected face, I'm going to have the coordinates, the top, the bottom, the right, the left, so I can draw a frame around the face. So with all these 4 values, I'm going to say Opencv, draw a frame here, and that's it. And I am going to show the battery again to double check what we have. So we have this face, go back here, let's show the files, there it is, the face, and I'm probably not connected. Yes, I am not connected, so let me turn on the drone and connect again. I told you that I'm going to use this a lot during the session, so that's why I explained at the beginning. So it's not connecting. Let's do this again one more time. There it is, it's connected. So I will go here and I will go for Python, face PI, and then I will have the camera view. Oh, no, that's correct. I ask Python to open my cascade file, the XML file here, the frontal face, but in my folder I don't have it. So what I need to do is I need to copy this and paste this in the specific location. Sorry about that, I forget. Now I have my face, I have cascade frontal face default XML. So I will run, and once it's running and open the face cascade, there it is. I can start to move my drone around, and it's going to probably not detect any face here with the figurines. Maybe yes. So green arrow is a face. If I point it to myself, put it in this way, there it is, there is my face. So it's very decent. It's kind of fine how it works. As I said, this is not the best algorithm to work to use this, but it works great. And what I can do here, and I like to do also, is to, let me go here, is to show you let me open a video from the global AI community. Hey, my name. Let me mute the video and show you here how it's detecting face in real time. All of this problem with the streaming is because I have a lot of devices here, so the Wi-Fi is basically getting crippled, but you can probably see how from time to time it's detecting and doing the red squares, the red frames around the faces, so it's kind of nice there. Let me, oh, where is my mouse? And start again. So you can take a look there, it's detecting 3, 4, 5, 6, 7 frames at the same time. It's kind of nice, and again, it's only 2 lines of code. I defined the cascade, And it's really cool that, hey, there, Hawkeye, it's your face. It's really cool that you have there, and it only took me, let me close this one, it only took me the definition for the fairy cascade, and when I have here, I can do the frames cascade analyze in each one of the frames, which is kind of easy to do, and once I have the frame, I can start to show. I have a demo here with the face and how is my time? I still have another 25 minutes. So I can show this also. I have another demo. Let me show you the demo. Still connected, yes. Which one is the one face detection 41? So Python 41. So this is the same demo, but showing also the frames per second. So here it is. So you can see the frames. Let me move the drone around. So you can see here it's detecting faces at 40, 30 frames per second. So the hard cascade is super freaking fast, and it basically doesn't affect a lot of the performance of the drone. But here it is. I kill my demo. This is Murphy. But it's not the best solution, but it's very easy to show you how when you have a frame here like this, you can change, you can analyze the frame and start to work. So when I have this up and running, and this is the moment that I probably need to close Python. So this is the moment that when I started to do this, I did a lot of other demos. I have other demos around how you can use and do mask recognition. So you can use your drone to check your face and check if you're using a mask or not. I'm going to show you this later. But this is the moment that I want to do something else, and I want to create my custom analyzer to detect my own my own objects. So there are a couple of ways to do this. If you work in the machine learning world, the ABC to do this is you need to start with data. Once you have all of this data, you're going to train a model, and then you're going to use the model. So this is the ABC of machine learning. If you need to do this and you never done this before, it's kind of tricky because you need to learn probably TensorFlow, how this works internally. You need to spend a lot of time. You need to use a lot of resources also to train this. But lucky for us, in the community services world, there is a specific service, the custom vision service, which is basically allows us to do the ABC, but in the visual way. We can upload image. Once we upload images, we can use these images to train a model. And once we have trained the model, we can use new images to see what we have there. Let me show you how this works, because custom vision is one of the probably coolest projects and objects that we have. So I have a couple of objects here. I have a couple of projects. Let me create a new project. Let's do this, the drawing for Code PaLOusa. And I'm going to do in the, and this is going to be classification for a single tag for image. And I can do a couple of things. I can pick up a picture and analyze a single picture for a one shot and say, this is a car, this is a bicycle, this is something else. Or I can do multi-layer. There are several ways things here. Or I can do object detection. In a single picture, here is a car and here is a bus, or something like this. I'm going to go fast here to do a classification multi-class, and then I can set there pre-trained models to analyze food, landmarks, retail. This is all general. So I will create the project. There it is. And once the project is created, I am going to start to add images. So once I have here my images, not this one, let's go here to my desktop, to custom vision models. I am going to start to add images. So I have drawing here, very simple drawings. This is fish, and this is probably a very old demo. So I will upload these 8 images, and I will say this is drawing of fish. I will add a tag. This is going to be fish, and I am going to upload my images. That's it. Let me upload a couple more images. Once I have my fish, I will add some flowers. So you can see here that I can add my tags, or I can even add negative tags. This is something amazing also. This is a flower. I will upload my flower, and then I am going to add images here about drawing, and I have some humans here. So very simple drawing, bodies, human, and then I upload this human. So that's it. I have everything here. All of my humans have 888. What I can do here right now, I can train a model. And when I train this model, what custom vision is going to do is going to basically analyze all of these images and create a model which is going to be able to work and give me the chance to do analysis in new pictures, in new photos, in new drawings, and say, hey, this is a human, this is a flower, or this is a fish, or I am 25% sure that this is a fish, which is not good enough for me. So this usually is fast. I don't know what is taking so long. Let's hope that, I know that there was some, there it is. So once the model is trained, I have a couple of AI metrics. I am not going to go deep there, but the next things about this is that I can publish this. I can publish this and I can create an HTTP endpoint, which is going to be for me available to post new images, and it's going to analyze these images. So let me show you one sample. Let's go here, open one of the coolest tools ever, Paint. I am drawing a fish, an ugly fish, it's angry, and this is Code PaLOusa. I will save this in the desktop as fishy, and I can go back to my project here, go to the quick test, browse a local file, and we go back to my desktop, open fish, and it's going to analyze, and it says that, hey, this model that you just trained thinks that this drawing is 100% a fish. Let me show you a couple of other things. If I draw here a flower, and again, sorry, Code PaLOusa 2020, sorry for the crappy drawing. This flower is kind of tricky because it has a face there, so I don't know what the model is going to do, but if I go here and pick up my flower, this is a 99.9 sure that this is a flower. So you take a look at what is going. If I go here and, oops, not this, let me go and draw. There it is, draw, boldest one. If I draw here a body, and I save it, let's see what's happening with this body. This is a fish. Somehow my model detects this as a fish. So you take a look how this works. I create a model, I upload images, and I trained the model. I started to test the model. This is very important. I don't want to have some problems here. If I get a new one, like in example, if I draw, I don't know, a hashtag, and I start to use it here, quick test, and I upload the hashtag. Where's my hashtag? It says that this is a fish. So you have the sense that this is not a very good model, but give you the sense of uploading, training, and use it, how cool it is. The next thing that I can do, I can go for my predictions. I can go here and say, hey, yes, this is a fish, so this is fine. I am going to save and close this one. And then I am going to go here and say, this is a flower, so this is fine, save and close here. And then I'm going to open here and say, no, this is a human. You know what? This is not well trained. And this is going to be on the negative side. I don't want to have any with this. So I will have more pictures here, and I can train my model again here. I can do a quick training. I can't do this again because I don't have enough negative flowers, but I can make my model better and better and better. And the cool thing about this is that at any time, if I want to use this model, in the one that I trained, I have this prediction URL that I can use to post an image, and I will have a JSON response about, hey, this is what you just analyzed, and I found a fish, and the fish is 20%, and I found a human, and a human is 80%. So, hey, I understand that this is probably more a human than a fish, but I can use this. So with all this in mind, I will start to think, okay, how can I create a model to do something with my draw? So I created another type of model, which is not the classification, is the object detection. And what I use is picture of my MVP world, when I have all of the MVP awards here, and I selected each one of the MVPs and I tag them. So you can see here, I can select a region and I can add a tag. What I did here, I selected all of these MVPs here and I put them in the this picture. So I have 6 here, and I have some horizontal and vertical, 6 in one shot, 4 in another shot, a single one, which is kind of tilted, it's not very well balanced. I have everything here, and I train a model. I have trained this model, and the nice things about training this model is that I have some decent values here, so a nice precision, recall, and map. But another cool thing that we can do with custom vision is we can export this model to be used on the edge or on another platform. Because if you think about this, if I want for every frame that I have from my drone to analyze these frames, send it to the cloud, and get it back and displays the results, it's going to be not very, very fast. I mean, this is not big images, but this is use a lot of bandwidth, so it's not the ideal scenario. But here, using custom vision, what I can do is once I have my model trained, I can export my model. And what I did here, I have the option to export this to use in an iPhone, example, or in an Android using TensorFlow, or locally as an Onyx file. Onyx is kind of the standard default that we can use, or as a Docker file. And this is amazing. I can export this as a Docker image for Linux, Windows, or even the Raspberry Pi. I don't have anyone here. And once I have this exported for one of these platforms, I can create a container, and this container is going to be creating a web host that is going to receive images and give me the response for this. So I exported this as a Linux version, and I installed it locally in my machine. So let me show you here. I'm using, we can do this in 2 different ways. If I go for show you the image that I have here, I have a lot of images here, but one of the images is the MVP award detector. So here in my image, I am not a fan of the command line, so I used Portainer. Portainer is freaking cool. I have a lot of images here, and one of the images that I have is the MVP. Where is the MVP? In the next, there it is. The MVP award detector, here it is. I created this a couple of times ago, and it's going to basically open a TCP HTTP server on the port 8070. It has a lot of things internally. I can show you the generated code here. And I have right now here a container image working here, which is the MVP award detector running at this port. So if I go here and I see the logs, I have all of the logs which happen here, and I can make a post here running to the, let me minimize this. This is Postman. I'm going to call localhost 8017 image, and I'm going to make a post call, and in the body, let me attach one of the MVP files. So I can attach, let's do a single one, and do this one that had 6. So I'm going to post this. You see in the log in the bottom how it's going to show information. And what I have as a response here is I have a JSON with, I found here an MVP tag, 95% sure that this is an MVP tag, and the bounding box, the frame detected is here, here, here. So I know that there, somewhere there is my MVP tag. So it's kind of working, it's kind of nice. So I can start to, instead of calling to the public website of Azure in the southwest code, I think it is, I can call locally and make the calls to detect objects here. So with all of this here on top, what I created, let me go back to John here, I created the full demo that, let's go down, that once I read the camera frame, I resize the camera frame precisely to have a decent frame. I will save the images to this. I'll show you later why. And I am going to post the image to my local drone, to my local Docker container. So that with this, I am going to basically analyze the image of the drone. And for this, I'm going to look for MVP awards. And I am going to show this. The way that this works is, there's a lot of codes here. I don't want to go into details, but basically I'm analyzing JSON. I'm sorting these by predictions. So I have all of my predictions. So I want to have the first, which are the biggest one, 90%, 80%, something. I am going to sort my predictions where the probability is sorted by probability. And then I am going to check by a threshold. My threshold is 50%. Usually you are not going to use 50. You want bigger. up to bigger than 85, depends on your model. But when I found a probability bigger than 50%, I am going to do some math here to get the specific location in the picture of the bounding box, and then I am going to draw the bounding boxes. That's it. What I am going to do here, I am going to print information, do a couple of things, and save images. This is extra information, but keep in mind this. Open the camera, get the frames, analyze the frame using a local document container, and display this. So that's basically it. Let's run this so you can take a look how this is working in action. So I probably not connected to my drone, that's for sure. Oh my God, I close. I didn't want to close this one. Let's go open this one and copy path. So here I am. I am not connected, so let's connect again. It's connecting. One extra topic that I forget to mention here is that while this is connecting, in the code here, I am not analyzing the code all the time. I have a flag here, and the flag is enabled when I press the letter D in my keyboard. This is to basically not have everything all the time. When I point the drone in the right direction, this is the moment that I want to have this. So should be connected right now. Yes, we are connected. And here we are going to do Python 66, complete, and I'm going to start to run. So we have here the camera. I can probably leave Portainer here in the somehow in the. So you can take a look. Every time that I detect a new MVP logo, the login, the button is going to show the logo. So I can start to move the drone around, pointed to the MVP wall, and if I press the V key, it's going to start. Take a look here how it's detecting the MVPs there. So it's basically there, and it's basically detecting the MVP. For each one detected MVP, I will show the detected information, and I will show how it works. But what is really cool here is that I can put the drone in the floor, and I can control the drone with my phone. I have a phone here, so I am going to use the phone app to control the phone. Let me connect to the drone, and I am going to show you how this, when it's flying in real time, is detecting they are the MVPs. So perfect, I am connected. Switching back to the drone application. Oh, there it is. It's connected, and once it's connected, I will start to fly the drone. This is the tricky part. This is the part where you need to believe me that it's flying. So he's detecting a couple of them. Woo! So that's what the drone controlling while it was flying. I know that it's kind of crappy to see all of this happen in real time, but let me show you one cool thing, and we also have 5 minutes for Q&A. While I was doing this, I was also recording all of the detected pictures in this detected folder. So here you can see that, I don't know, the date. Probably need to sort by today's ones. This is all the detected picture. I am saving in a local folder the JSON response and the detected pictures of every frame that's got something. So you see here, I have detected a couple of MVPs. That's fine. All of the JSON files, I don't want to open these. They will be big. But in the JSON files, what I have is the same JSON that I have here with the created, the date, and the bounding box, and the tags, everything better than 50%. So this is the very, very fast view of how we can do this, what we just did. So let me give you the ABC, a quick recap of what we have. First, there is no SDK. Lucky for me to play with the drone. Lucky for me, the drone has this PDF that allows me to interact. So that was great. I learned a lot in Python about multi-threading, sockets, and all of these things, which was kind of a cool experience to do this. Then I learned a lot about how we can do Opencv and camera, working with frames. It's nice to do this. Later, when you start to do custom object recognition, you can do face detection, you can train your own models, you can do more things. It's also nice to have. It's also nice to have these demos available there in order to do this. And finally, if you want to use your own models, you want to create your own models, Custom Vision AI is an amazing tool. And then you can, if you want to really use it, you can export them as a container, use it locally or another place. You can even put all together in a Raspberry Pi, and it works literally in the edge. So it's very, very easy. I'm going to share all of the slides. Here I have all of the resources that I've used. I have a couple of extra whys, that blog post that I write about how you can create and use your own environment for 2Ds, because you need to do Python and OpenCV is kind of tricky, but Anaconda helps you a lot here. How you can do segmentation of fixed emails and do this in Windows Terminal or outside. There is a lot of things. I have a demo where basically analyze faces and find the face. When I find a face, I'm going to do a flip. There's a lot of info there. So that's my info there, and I will open for questions right now. I still have 3 more minutes. Sorry about that. This is a long demo. This is a long session, but hey, I hope it makes sense and you all can go in this path. I will open for questions, read the comments, and I hope you like it. Okay, it seems that we don't have any questions in the chat window, so I will call it a day. That's been amazing, and thank you very much. Thanks, Rebecca, for the support, and see you on the next one. Goodbye.